Imagine for a moment that you could unveil one of the darkest secrets of the universe. A mystery so profound that even the greatest scientists in history tremble when confronting it. The darkness of time. Why do the past and future differ in such a disturbing way? We all believe we know time, like a river that flows inexorably from past to future. But what if I told you that this certainty is merely an illusion? That there's something far more sinister behind this apparent simplicity? An invisible thread of destiny that continues presenting itself before us, but whose origin remains shrouded in darkness. Welcome, brave explorers of the unknown, to Quantum Horizons, where together we dare to penetrate the most terrifying secrets of the cosmos. Secrets that science barely dares to whisper. If you feel your heart race before mysteries that challenge our entire understanding of the universe, if you yearn for revolutionary discoveries that are silently rewriting our reality, then subscribe now and leave your like to embark on this journey through the darkest and most unexplored corners of space-time. Prepare yourself to examine a question that few have the courage to ask. At first glance, past and future seem like completely separate worlds divided by an impassable abyss. You can remember the past with an almost painful clarity, but the future remains a forbidden territory to your memory. You can never go back in time, never prevent your own aging. You can remain motionless in space, but in time? Impossible. It never stops, never hesitates, never offers mercy. This hauntingly evident difference between past and future reveals itself disturbingly when we watch events happening in reverse. When we perceive something moving backward, a chill runs down our spine. We instantly recognize that time has turned, that something fundamental has been violated. We know, with a certainty that terrifies us, that we will never witness such an event happening spontaneously in nature. But here's what will make you question everything you believe you know about reality. When we examine the fundamental laws of physics, something truly disturbing emerges from the shadows. These laws make no difference whatsoever between past and future. They are temporally symmetric, as if the universe guards a terrible secret about the nature of time. Imagine two red spheres colliding in the vacuum of space. If you observed this collision, it would be impossible to determine whether the video is being played forward or backward. The equations governing their movement are identical in both temporal directions. At the most fundamental level, physics recognizes no absolute before or after. Time is just a cold variable, without preferential direction. But if the laws of physics are symmetric, why does our daily experience scream the opposite? Why do we remember the past but not the future? Why do we feel this inexorable sensation that time possesses a defined direction, like an invisible force dragging us toward an unknown destiny? The answer may be hidden in a disturbing analogy. In space, there is no natural difference between up and down. All directions are equivalent in the cosmic vacuum. But here on Earth, we clearly distinguish these directions because gravity pulls us relentlessly downward. Spatial symmetry is broken by Earth's presence, defining a preferential direction. Something similarly sinister may be happening with temporal symmetry. To understand why the fundamental laws of physics seem to lose their temporal symmetry, why this hauntingly real difference exists between past and future, we must dive into the dark foundations of thermodynamics, into the terrifying vastness of the universe, and into the disturbing relationship between time and entropy. The answer may be closer than we imagine, and it could completely revolutionize our understanding of time. Consider now a more complex and disturbing system: multiple spheres in motion. Imagine a video where one sphere collides with several others initially at rest. Played normally, nothing seems unusual. But when played in reverse, something profoundly unsettling happens. We instantly recognize that the temporal direction has been inverted, just as we would recognize a broken glass magically reassembling itself. But why do we have this disturbing certainty? Actually, in the reversed video there's nothing physically impossible. It's perfectly possible to write equations describing this movement. What makes this hauntingly unusual is the extremely specific initial precision required. Each sphere would need to possess perfect initial velocity and exact position for all to converge at the same point, at the same instant, stop simultaneously, and allow another sphere to move away. The reversed video seems so disturbing because such an extraordinary coincidence almost never happens in nature. Now you're beginning to discover why past and future seem so different to us. If you still don't fully comprehend, allow me to present another example that will haunt you. Imagine two photographs of an egg, one showing the whole egg, the other showing it broken and scattered. If we asked which represents the past and which the future, you would answer without hesitation that the whole egg indicates the past, while the broken egg represents the future. The same happens with a glass shattering on the floor. Why do we possess this almost supernatural certainty about temporal order? Because in nature we never witness a broken egg spontaneously reassembling itself, or a shattered glass magically returning to its original form. These are events that follow a defined and terrifying direction. In physics, we call these irreversible processes, as they cannot be reversed. At the microscopic level, however, all atoms and molecules of the egg and glass move and collide randomly, like the spheres in our first example. At this microscopic scale, processes have no preferential temporal direction. Where then resides this dark secret? The secret lies in the disturbing fact that the egg and glass are composed of an astronomical number of molecules, and there are infinitely more ways for these molecules to organize themselves in a broken and disordered state than in an intact and ordered state. For the reversed process to occur, each molecule would need to move with perfect synchrony, a coordination that defies probabilities in a haunting way. It is extremely unlikely that molecules would spontaneously organize in a way that returns to original conditions. This probabilistic asymmetry is what forces time to flow in a single direction. For a broken egg to spontaneously reassemble, extremely specific and almost impossible conditions would be necessary. All molecules and atoms would need to move with exactly precise velocity and direction. The probability of a broken egg reassembling itself is immensely smaller than the probability of another intact egg breaking. Furthermore, in any process of this nature, energy is released as heat. By the principle of energy conservation, we know that energy cannot be created or destroyed, only transformed from one form to another. Heat, however, is a special form of energy. Once dissipated, it cannot be completely recovered to perform useful work. Although it still exists in the system, it becomes unusable for practical purposes. The amount of usable energy in a system connects directly with a fundamental and disturbing property called entropy. When we heat a piece of metal, the entropy of the metal and surrounding environment increases inexorably. Entropy can also be understood as the measure of possibilities a system possesses to alter its macroscopic properties. In the egg's case, an intact egg possesses lower entropy than a broken egg, since only a very specific molecular organization can maintain the shell structure intact. In contrast, molecules of a broken egg possess a disordered configuration, with infinite arrangement possibilities, making return to the original state extremely improbable. When all molecules spread randomly without any reference to the original form, the egg reaches its maximum entropy. In nature, entropy always increases. This behavior is one of the most fundamental and terrifying principles of physics, the second law of thermodynamics. The reason is hauntingly simple. There are many more ways to increase disorder than to decrease it. Thus, the probability of spontaneous entropy decrease is practically null. This law also offers us a fundamental and disturbing definition of time. Time always flows in the direction of increasing entropy. Every irreversible natural process follows this dark path, allowing us to distinguish past from future. We can order events temporally because the future always corresponds to a state of higher entropy than the past. This logic also explains why we perceive the past as more concrete and defined than the future. Our brain processes environmental information to reconstruct past events and predict futures. However, since entropy only increases, past reconstruction is always more reliable than future prediction. The quantity of previous states that led to the present moment is infinitely smaller than the quantity of possibilities the future offers. Even when we form a new memory, this process is based on increasing system entropy. Entropy is irreversible, can only grow in one direction, never decrease. We perceive the past because past uncertainty is always smaller than future uncertainty. This results from a fundamental and mysterious property of our universe. Our cosmos was born in a state of extremely low entropy. Today this level is higher than in the past, but still lower than it will be in the future. If the universe had been born in the state of maximum possible entropy, with all particles in random motion and total thermal equilibrium, nothing significant would have happened. There would be no stars, galaxies, or any organized structure. Without these fundamental differences, it would be impossible to distinguish past from future. The universe, however, evolved from an extremely homogeneous state to an extremely complex and structured state. The formation of planets, stars, galaxies, and even the emergence of life are manifestations of this haunting process. Therefore, time's unidirectional flow connects directly with the fact that past entropy was lower and continues increasing inexorably. But for how long will this continue? Nobody knows for certain. What we can affirm is that, so far, the difference between past and future becomes increasingly pronounced and terrifying. If you have more questions about entropy and its disturbing relationship with time, share them in the comments. Thank you very much for having the courage to watch this disturbing video, and we'll meet again in the next one. And thus, brave explorers of the inexplicable, we reach the end of this transcendental journey through existence's darkest mysteries. If these disturbing revelations touched your soul and awakened questions you didn't even know you possessed, strengthen our community of truth seekers by subscribing to Quantum Horizons, your portal to reality and consciousness's deepest and most haunting secrets. Your like is not just a gesture, it's fundamental for expanding this mission of discovery through knowledge's forbidden territories. In the comments, share the unsettling sensations these narratives awakened in you. We want to know your personal experiences, your most daring theories, and your feelings about these mysterious worlds that dwell beyond common perception. Thank you for having the courage to accompany us on this extraordinary exploration through existence's darkest corners. The adventure through the unknown secrets is just beginning. Together, we will continue unveiling the universe and human mind's most profound and disturbing enigmas, even if it means confronting truths that humanity is not yet ready to understand.